Oh no, weird looking blocks behind me. It must be snapshot day. That's right, Mojang has added 5 new, interesting looking blocks into the game. This is vanilla Minecraft, and I'm on the latest snapshot. And you're probably asking, what on earth do these do? Why were they added? And how do I use them? And my hope today is to explain that to the best of my ability. Now, before I dive into the functionality of the individual blocks themselves, I want to give a little bit of context for the greater game feature that these blocks are a part of. Mojang has basically added unit tests to Minecraft. Now, if you aren't aware of what a unit test is, it's a common concept in software engineering where you want to be able to test features of your software in a closed and controlled environment. So for example, if I was creating a data pack, I could do something along the lines of writing a function that instantiates every single aspect of the data pack and make sure that it works correctly. If it finds something behaving not as expected, it might give me an error message, and if all of them work properly, it will give me a success message. Now, you can very easily do that if you are controlling the code of whatever your project is. Like if it's a data pack or I'm writing a Java program, it's very easy to add unit tests. But what Mojang have added to the game is the ability for players to test features of the game without even touching the source code. Okay, but enough talking about it. Let me show you how this game test system actually works. These blocks exist to allow a player to create what's called a test instance. So to start, you need this first block, the test instance block. And by the way, if you're wondering how you get these blocks, you can find them in the operator utilities tab. They're right here lined up. Now, if you've never enabled that tab, all you have to do is go into options and then controls and click operator items tab right here, and then you should be able to look in that tab. So to create a test instance, the first thing you're going to do is place down this test instance block. And in some ways, this block acts a little bit like a structure block. You can use these 3 fields to control the size of the bounding box that you're going to be working with. So I will just say, let's do a 5 by 5 by 5 bounding box. If I just click done, the box will appear. Now, unlike structure blocks, this bounding box always appears in the same place relative to the test instance block. It's always on this weird corner right here. So that's just something you have to get used to, and I'm hoping they change that in a future snapshot. And then inside this box, you're going to be setting up what's basically a redstone circuit. So yes, I had to actually learn some redstone for this video. And just real quick, I'm actually going to move the block 1 block down so that the box is now sitting on the floor. And once we have this box up, we have to be thinking about what the test is going to do. You can basically think of a test as an event that runs. When you run the test, whatever you've put in this box will get placed down, the test will run, and then eventually it'll be over. When the test first starts, if there's one of these blocks inside the box, it will send out a redstone pulse to signal that the test has started. So this block is aptly called the start block. Now, after the test has started, if any one of these blocks receives a redstone pulse, different things can happen. When this block receives a pulse, a message will get logged to the server logs. And as we'll see in a minute, it's only the server logs, and it does not show up in chat, so you'll have to be watching your logs pretty closely. And finally, these 2 blocks control the end of the test. If this block receives a pulse, it will denote that the test was a success and the test will stop. If this one receives a pulse, it will denote that the test failed, and then it will also stop. So if you're ever designing a unit test for one of your projects, you want to design the build in such a way that the redstone activates this block if everything is working correctly, but if for some reason something is not working as you expected, it'll send a pulse to this block. Alright, let's look at an example. I've gone ahead and actually built a little test right here. Now, the purpose of this test is to determine whether the sun is up. Now, this is not really typically a unit test. I mean, for unit test, if everything is working correctly, it should always go to the success block. But I wanted to do something that's really easy to change a setting, and then we can see the difference between success and failure. So this is a test that will succeed if the sun is up, and it will fail if the sun is not up. Now, like I said, whenever the test starts, this start block will send out a redstone pulse, and the first thing that'll happen is that this repeater will send a pulse into this message block, and the message will print "the test is running" into the server logs. The start block also sends a redstone pulse this way, which disables these torches. Now, these torches are currently locking this repeater and this repeater. So when the start block pulses, those repeaters will become unlocked, and if the sun is up, this daylight sensor will output a signal into the success block, and meanwhile, if the sun is not up, this daylight sensor will enable this torch, which puts a signal into the fail block. And yeah, I know there was probably a much more efficient way to do this, but I'm bad at redstone, don't worry about it. But as you can see, I have used every single one of the test blocks, including the test instance block, which is down here, and I'm using it to save this structure. Now, like I said, these blocks are similar to structure blocks. You can save the structure in exactly the way you would with a structure block, the difference being that you don't get a message in chat. You kind of just have to trust that it's saved correctly. And now your next question is probably, how do we run the test? We've got it all set up, how do we actually make it activate? And for this, believe it or not, we're gonna need data packs. So, to help us with this tutorial, I've made made us a new data pack, and I'm under data and a namespace which I've called example, and there's two new data pack folder types. There's test environment and test instance. Now the test instances are the actual tests that you can run either with a command or with that test block. So I've gone ahead and made a new test instance that I've just called sample test, and you can see that the file's not that big, but there actually kind of is a lot going on here behind the scenes. I'll zoom in a little bit so you can see it better. First off, my type is block based, and I always need to set it to that type if I'm going to be running a test using these new blocks. There's another type that's called function, and that one is only usable by mods, so you can't do it in vanilla. If you're doing something purely data pack based with no mods, you've got to make it block based. Next up we have the structure, which I've said example sample test structure. This is just the name of the structure that I saved, so if you look in this block, that's the name that I put right up here. The next field is batch. Now for this one, you have to not trust the changelog. I've got the changelog pulled up right here, and if you've been reading through this, you may have found this field called environment, and it says it's the namespace ID of the test environment to run this test as part of. That field is not called environment, it's called batch. If you try to put environment here, the server will not start. And the only reason I found that out was because I went digging through the vanilla data pack. If they hadn't provided a default sample test in the vanilla data pack, I never would have solved this. As for what this field actually points to, this is the other file that I will be covering in just a second. And then finally we've got max ticks, which I've set to 60, which is 3 seconds. If the test is actively running for longer than that time, it will consider itself timed out. And this is just a simple redstone circuit. It should run in less than a second, so that's why I set the max ticks to something really low. If this somehow manages to take 3 seconds, then something went wrong. So if you're going to define one of these unit tests, you need to have this file in your data pack, or something that looks like it. Now that was under test instance, and the next one I'm going to show you is test environment. In the test instance file, I pointed to something that was called example sample environment, and that is this file right here. The environment is kind of exactly what it sounds like. It just acts as an environment to set up before the test gets run. You don't have to define one, and if you're not going to define one, you want to put this as Minecraft default, like that, and in that case there will be nothing special about the environment. You're kind of just running the same way the game normally is. However, I've gone ahead and made my own. It's this sample environment, which is right here, and I've just said it is a function type of environment which has a setup function and a teardown function. Now in the changelog right here, it tells you all the different types of environments you can have. I picked the function one, but apparently there's also one to change game rules, there's one to change the weather, and then there's one to change the time of day as well. And these environments basically just apply a change for the duration of the test, and then I'm pretty sure they undo that change at the end. So like if you wanted to change the game rules just for the duration of the test, you'd be able to set the new game rule values and then have them return to their default values once the test is done. Personally, I tried the weather one, and the weather one didn't work. It seemed like it doesn't exist. So I don't know what's going on with that. They might have just written something wrong in the changelog again, but I know the function one does work, and that's what I'm using. So I've got a setup function and a teardown function. I've just programmed some example functions. They're just functions like you normally would run in a data pack under the function folder. Setup just prints a message that the test has started, and then teardown just prints a message that the test has ended. Alright, and that's all there is to it. I have now successfully set up a test in my data pack. Now if you were following along with me and you set up this test yourself while I was talking, you will have to restart your server in order for it to take effect, because these tests aren't reloadable, but I already had these loaded into the server, so I'm just going to go ahead and run the test and show you how it works. So the easiest way to run a test is, assuming you have everything in the data pack loaded and you have this thing saved to your world, which I just did, you want to go maybe kind of far away from it, and you want to say /test run, and then you'll see the name of your test. So I have example sample test right there, and if I just run that, well, you can see what happened. It placed down the structure and a bunch of stuff got printed to the chat. So the server said the test has started. That was because of my setup function. And then the redstone detected that the sun is indeed up, so this circuit activated. It activated the success block, and that's why we got this test passed message. It says all required test passed. And then finally, at the end, the teardown function happened, so the server just said the test has ended. Now, one thing you'll notice in these chats is that the message from this message block over here, which says the test is running, does not appear. You have to actually open up your server console and see where that got printed, and it printed twice. It always does that for some reason. I'm not really sure why. It's probably a bug. But you can see there's a test log and it says the test is running, which is exactly what I put in this block. It also spawned one of these test instance blocks. Gives me a little bit of data and information about the test that I just ran. And it has a green beacon because the test was successful. You may have noticed earlier in the video it had a gray beacon while the test was actively running. And now I will go ahead and set the time to 18,000, which is midnight, so we can run this again. I control middle clicked that block, so I just grabbed all its data, and I will have it reset and load. And now I'm going to show you the other way to run a test, which is if you don't want to use the command, you can also run it just straight out of this block. So you can see everything is set up, and if I just go into the block and press run test, it will run, and because the sun is not up, the test has failed. Now something else weird is that when it fails, it keeps this box of barrier blocks around it, but when it succeeds, it doesn't. Again, I don't really know what that's about, but seems to just be the way it is. But obviously now the beacon coming out of the structure instance block is red because the test failed. And as far as game tests go, at least from the data pack side, that appears to be all there is to it. You build a contraption like this, and then you put those data pack files in that I showed you earlier, and then you are able to run unit tests to test if something is the way you want it to be. Or in my case, the way I want it to be, quote unquote, is just for the sun to be up. And now that I've done that, I actually have a data pack that I can export. All these files are in place. The one thing I have to remember to do is to actually put the structure into the data pack. So like I said earlier, the structures save in exactly the same way structure blocks do. So if I am just in my world folder, I go to generated and then namespace and structures, and then I find my structure. I can say Control X to cut it, go back into the data pack, add a folder called structure, and then underneath structure I can just paste the file that I copied earlier. And now finally this data pack is fully complete and ready to be exported. Now obviously I haven't covered every tiny little detail of what you can do with game tests, and in particular I have not covered the other method, which is the modding method. Hopefully though this video gave you a little overview and kind of a general picture of what these game tests actually do, how they work, etc. And I'll leave the full changelog down in the description so you can read up on all the finer details if you want to. But remember that it seems not everything they wrote in the changelog is actually right, so it's, you'll kind of have to play around and see what actually works. I've left the data pack that I just created as a zip folder down in the description below, so you can get it and look at it if you want to. And with that, I think that's going to do it. I've been Kanye, as always. Thanks for watching, my dudes.